Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this AWS Data Engineering Certification course, and in this particular video we are going to see how using a Lambda function we will be able to access our Amazon RDS instance. So in the previous few videos we have already seen how we will be able to launch our RDS instance, and depending on what kind of database engine do we want to use, we will be able to launch an RDS instance containing that particular database engine. So we have already talked about MariaDB, we have talked about Oracle database, we have talked about Microsoft SQL Server database, and we have talked about MySQL database. In all these videos, we were not only launching the RDS instance, but we were also connecting the RDS instance to an EC2 instance, which was in the public subnet, whereas our RDS instance was in a private subnet, which was not publicly accessible over the internet. So we were also following the security and the I would say the security and the audit compliances that are there for creating and securing the database. So if you haven't watched any video in of those particular database engines, I would highly recommend you to watch at least one video, and then you should continue watching this particular video so that you have some context that what we are talking about in this particular video. You need not watch all the videos, but if you watch even one video, you will be able to understand that how we are doing the things over there. So with that said, let's get started with this video and let's get straight into the system. So as already talked about that in this tutorial or in this video, we will be using a Lambda function to access an Amazon RDS database. So in this tutorial, you use a Lambda function to write a data on Amazon relational database service database through RDS proxy. Your Lambda function reads records from an Amazon SQS, that is a simple queue service queue, and writes a new item into a table into your database whenever a message is added. In this example, you use a AWS management console to manually add messages to the queue. The following diagram shows the AWS resource you use to complete this tutorial. Okay, so we will have an AWS management console, that is our UI, right, of our AWS. Here we will be having some kind of queue. So queue is similar, or you can say is a similar kind of data structure that we have inside the DSA, if you have learned. If not, if you are aware about Python, right, so we have something called as list, or maybe any kind of you can say any kind of list or array kind of objects that we have inside the Python, that is list. It may be a dictionary, it may be a tuple, it may be a set, right? So those kind of data structures, I would say, can be equivalent to a queue. I'm not saying that it's exactly a queue, but it can be considered as equals to a queue, where we will have something like this, right? I can keep it as gray and transparent. Okay, so our queue will look something like this itself. So let me keep it as gray, right, where we will be having our data, and the data will mostly be in a form of uh, FIFO, right? So here, so I'm just putting in these values. These values can be anything, right? I hope you guys are aware about this fact. I'm putting here. Okay, so this is a kind of a queue that we are talking about. So this will be a service called as simple queue service, that we in short called as SQS. Okay, so we will have an SQS first of all. Okay, this SQS will trigger what? It will trigger a Lambda function. Okay, so this SQS, it will be connected to a Lambda function Okay. So as soon as a new data gets added to this particular queue, this Lambda will get triggered. Okay. AWS Lambda. So this Lambda function will get triggered, and using the RDS proxy, we will be able to store, and we will be connecting this particular Lambda function to this RDS proxy. And using this RDS proxy, we will be able to store whatever the data is getting added to this particular queue to our Amazon RDS database instance. So here I can say, let's say this is my database instance, or I can say my RDS instance. Okay. So there will be a proxy here. So what is proxy? I'll be talking about it. Don't worry. Let's use the Azure one itself. Okay. So it will be communicating via this proxy, the Lambda function, and this proxy will be communicating to the RDS instance, and we will have a database here inside our RDS instance. Cool. So this is somewhat our architecture will look like for this particular tutorial. Okay. And we will be interacting with this. So this queue, ideally, it should have some kind of sorry. So the data in this particular queue can get produced ideally with some kind of maybe a web app, maybe a mobile app, maybe some kind of IoT device, maybe some other data source. But here for this particular video, we will have our AWS console itself. Okay. So is it there in yes console? Let's use this figure only. Okay. Let's not use this figure. Okay. Maybe a laptop, you can say, using a laptop. Okay. Our own personal laptop via this AWS console. We will be interacting with this SQS. Okay. And we will be inserting the data inside this SQS. Okay. So with Amazon RDS, you can run a managed relational database in the cloud using common database products like Microsoft SQL Server, MariaDB, MySQL, Oracle Database, and PostgreSQL. By using Lambda to access the database, you can read and write the data in response to events. Okay. So here, as I already told you, that when any kind of data will be added to our standard queue, right, this Lambda function will get triggered, and the addition of data to this particular queue can be considered as an event. Okay, it can be considered as an event, and the Lambda function will respond to this particular event, that is the data that is getting added to this particular queue, such as a new customer registering to your website, right? So ideally, as I told you, that this queue will contain some kind of a data source. It can be a website, an application, a IoT device, a SaaS, right? Maybe some kind of other data store, right? Maybe some kind of you can say a geolocation device and whatnot. Anything can be there, a sensor, right? Any kind of data or any kind of device that produces data can be a data source for the SQS. Okay, such as a new customer registering to your website, your function, database instance, and the proxy scale automatically to meet the periods of high demand. Okay, so our Lambda function, right, our database instance, and the proxy server will be set to a kind of auto scaling, right, where it will automatically scale up and scale down based on the kind of traffic we have on our service. So to complete the tutorial, you carry out the following task. First of all, launch an RDS for MySQL database instance and a proxy in your AWS accounts default VPC. Then create and test a Lambda function that creates a new table in your database and writes data to it. Then create an Amazon SQS queue and configure it to invoke your Lambda function whenever a new message is added. Test the complete setup by adding messages to your queue using the Amazon Management Console and monitoring the results using CloudWatch logs. So by completing these steps, you will learn how to use Amazon RDS to create a database instance and a proxy and connect a Lambda function to the proxy, how to use Lambda to perform create and read operations on the Amazon RDS database, and how to use Amazon SQS to invoke a Lambda function. You can complete this tutorial using AWS Management Console and AWS command line interface, right? So using any of the tools, that is AWS Management Console or AWS CLI, we will be able to achieve these all things. Okay. So what first of all we will do is we will try to launch an RDS instance, right, which will have the database engine as MySQL database. We have already done this particular thing, so I don't think it should be a hurdle for you guys. Yes, setting up a proxy is something that we have not done, and we will try to see that how we will be able to set up a proxy using which we will be interacting with our Lambda function, and then we will test and create a Lambda function that will create a table in our database, and it can also write data to the table. Then we will try to create a SQS queue, that is a simple queue service queue, right? And we will configure it, right, so that it invokes the Lambda function every time a new data or a new message is added to the queue, right? So message is equivalent to data inside a queue. So just like we say, let's suppose a new data or a new row gets added to a table. Similarly, if it is a SQL service or if it is a queue, so we will say it as a message, that a new message has been added to the queue. And then we will test the complete setup, right, using which what we will do is, by using AWS Management Console, we will try to add new messages to the queue, and that new message should be inserted and written into the table of the RDS instance. And this is what we have to achieve. And we will be able to learn that how we can use Amazon RDS to create a database instance, right, and to create a proxy and to connect it using a Lambda function. We will also be able to learn that how we can use Lambda to perform read and write operations on the Amazon RDS database, as well as we will also try to learn how we can use SQS to invoke a Lambda function. So prerequisites. So before you begin, complete the following sections, that you have to sign up for an AWS account and you have to create a user with an administrative access, right? So again, we have already seen that how we will be able to sign up to for an AWS account means how we will be able to create an AWS account, right? Unless we don't have an AWS account, we will not be able to access any of the services. Now, once our AWS account has been created, the main account that we have created is usually called as a root account, right? And it is suggested by the AWS developers that we should not use a root account for our day-to-day tasks. We should only use the root account for the administrative purposes. Means maybe for creating a new user, maybe for giving the kind of I would say access to the users, and all these things should be done, and only these things should be done from the root account. Okay, so what we will do is, from the root account we will create another user, right? We will create another user, or you can say a sub user from our root account, which will have the administrative access to it. Means it will have the access of all the services present in our account. Okay, so we will have an administrative access or an admin account from our root account, and using that admin account only we will be doing this particular tutorial. Okay, so you can see here, so to create an Amazon RDS database instance, so first of all we have to create a database instance. Auto create Lambda function is to create role, create deployment package, test in console. SQS is to create queue, configure event source mapping, and then the fourth part will be test in console. So this is how exactly we will be following this particular tutorial. So in Amazon RDS database instance is an isolated database environment running in the AWS cloud. An instance can obtain one or more user created databases, right? So there will be a database, right, or the instance that we will be creating. So let's suppose this is the MySQL database instance that we have created. So it will be considered as a database itself, and inside this database we will be able to create multiple databases. Okay. So unless you specify otherwise, Amazon RDS creates new database instances in the default VPC included in the AWS account. For more information about Amazon VPC, see this particular link. In this tutorial, you can create a new instance in your AWS account's default VPC and create a database named example database in that instance. You can create your database instance and the database using either the AWS Management Console or the CLI. So how we will be able to create the database instance is open the Amazon RDS console and choose create database. So first of all, let's log into our console. So as you can very clearly see here also, I am not using my root account to do the tutorial, right? I have created a user, right? IAM user, which I have named Vishal, right? And I have set up a password. This is my account ID or my user ID. Okay, and I will be able to sign in here. Cool. So now what we will do is, okay, just a second, guys. Okay, so the billing is due. Okay, no worries. I will get that done. Okay, so what here we will do is we will search for first of all RDS, right? So you will be able to see Aurora and RDS here, right? So we will try to select this Aurora and RDS, that is managed relational database service, and I will click on it. Okay, so we will be redirected to a dashboard of our RDS service, right? Next, what we have to do is leave the standard grade option selected and then choose the option as MySQL, okay, and all these things. So first of all, here what we will do is we will try to choose our location. So let's choose our location as Mumbai, because Mumbai is the closest location from where I am residing. Okay, so I'll choose the location as Mumbai. I will go here in the databases, okay, and I will click on this create database. Okay, and now what we have to do is leave the standard create option selected and then choose the database option as MySQL. Okay, so I will choose this and I will choose MySQL. So here we have to select the community version itself, and engine wise, let me go ahead with 8.0.43 itself, because there is no kind of version change, right? Here you can see Microsoft 5.7, right? And then there is 8.0 and 8.4, right? So we'll go ahead with 8.04 itself. No worries with that. So in the templates, choose free tier or sandbox. Free tier appears in the free tier account. Sandbox appears in the paid accounts. Okay, so here we can choose sandbox. Okay, so here again you will also be able to see if you are going ahead with the dev and test, right? Here we will be able to do the multi availability zone deployment, where we will have 3 instances. We will be able to do multiple multi availability zone deployment, where we will be able to have 2 instances, and here we can do single availability zone deployment also, where we will have only 1 instance, right? So in development or test mode and in the production mode, right? And if I talk about production, so you can see by default in the production mode it is automatically choosing the 3 instance deployment, right? where in this particular instance, what we will have is, we will have a primary instance, right? We will have one primary instance which will have the ability to read and write both. So let me just open the Epic Pen once. Okay, I don't need to update it now. I'll update later on. Okay. So here you can see that this will be my primary instance. Okay. So this will be the primary instance that we will be having, which will be deployed in availability zone 1, right? And this primary instance will be able to perform both read and write operation. Okay. So both of the operations and read and write endpoint will be here. Okay. So this primary instance will be able to perform both read and write operation. Now this primary instance will be connected to some kind of reader instance or reader endpoints, right? Because here we have three instances, so both of the reader instances will be deployed in a separate availability zone, right? So in the availability zone 2, one of the reader instance will be deployed, and in availability zone 3, one of the reader instance will be deployed. And you can very clearly see these are just the read instance and these are not the write instance. Okay. But with the help of this kind of architecture or with the help of this kind of deployment, what we can do is we can reduce the read and write time, right? We can drastically reduce the read and write time of our database. Now, some of you may ask that, okay, reducing the read time makes sense because we have multiple reader instances, right? So our read time will be reduced, but how our write time will be reduced, that is somewhat confusing, right? Or that does not make sense because in this particular deployment also we are having only one writer instance, right? We can only write to the primary instance. Here also we are having one writer instance. Here also we are having the single writer instance, right? So it is because, right, how we will be able to reduce the write time is, so let's say I am the user, okay, me as a user, right? And obviously there will be multiple users, right? So the structured databases, they follow a property called as ACID properties. Okay, they follow something called as ACID properties. Means, so ACID properties means, so A stands for atomicity. Means until and unless one operation is not performed, let's say there is an operation 1 that is a read operation, then we have an operation 2, right, that is also a read operation, then we have an operation 3, let's suppose this is also a read operation, and then we have our operation 4, that is a write operation, right? Then we have operation 5, that is a read operation, right? And then we have operation 6, that is a write operation. Okay, let's suppose we are having this particular, okay, let me do one thing, let me make you understand this particular thing using the diagram. Okay, so let me use a laptop. Okay, let me use a database. So this is a single instance deployment, let's suppose. Let me take, or let me only compare single instance deployment and uh, 3 instance deployment, right? Multi availability zone 3 instance deployment I will be comparing. Okay, so control C, control V, okay, control V. Let me make it a bit smaller. Control V, something like this. Okay, cool. So this is our single availability zone deployment. This is our single availability zone deployment, and this is our multi availability zone deployment, that too having 3 instances, and these 3 instances will have Okay, one read write instance and two read instance, read only. Okay, so or I can do it in this way. Maybe I can keep this particular thing in a different line. Cool. So here you can see this is my read write instance. Or I can say my primary instance. Okay, and the other two instances are write only instance. So these two are write only instance. Okay, now as I was talking about the ACID properties. Okay, so ACID properties, here A stands for atomicity, means again my SQL will also create some kind of queue. Let's suppose we are having multiple requests on the database at the very same time. It will try to create a kind of queue. Okay, so in the queue, let's suppose, so operation 1 is, let's say, a read operation, right? It has to read something. Then operation 2 is again a read operation, it has to read something, right? Then operation 3 is again, let's suppose, a read operation, it has to read something, right? Operation 4, let's suppose, is a write operation. Okay, operation 5, again, let's suppose it's a read operation, right? Operation 6 is a read operation. Okay, operation 7 is a read operation. Operation 8, let's say, is a read operation, and then operation 9, right, is a write operation. Okay, let's say these are the kind of operations, or you can say this is the proportion of read and write operations that we usually have for our database. Okay, again, if I talk about any kind of social media platform, right, so those social media platforms are usually having a very high read operation as compared to the write operation, right? Most of the people are on the platform watching maybe short videos, maybe consuming things, right, rather than uploading their maybe post or maybe some kind of reels or whatnot, right? So, and this is just to give you an example, right? In at most of the applications, right, even if I talk about the e-commerce data set, right, there also the number of read operations are very high as compared to the number of write operations. Okay, so let's say this is and again, like, if again I'm giving you an talking about these things in an example way only, right? Obviously I'm very much aware about the fact that the social media platforms and the e-commerce platforms, they don't generally use RDS databases, or I would say RDBMS databases for their use case. Okay, I'm just taking that particular thing as an example. Okay, now if I'm having a single availability zone deployment, in that case, how these things will work? Okay, let's say there are different users. Okay, there is a user 1. Okay, let me delete this laptop itself. And okay, there are different users that are there, right? So this user, so now this is the list of the transactions, I can say, that these users have created. Okay, these transactions are of these three users. Now what will happen is, let's suppose, okay, and let me do it in this way, or maybe let me keep only two user. Okay, to reduce the confusion, right? Now the read operation belongs to user 1. Okay, so this, all these read operations are of user 1. So this is of user 1, right? This is of user 1. Read operation again is of user 1. This write operation is of, let's say, user 2, right? And then user 1 has given us the read thing. user 1, maybe this is of user 2, let's say, right? And this is again user 1, okay? And let's say this is user 2, something like this, okay? So this is, he is u1, okay, and he is u2. Cool. Now what will happen is user 1 has sent a read request, right? So this request will be redirected where? It will be redirected to this database instance itself, right? So the read operation will be there. It will take some time and it will try to revert the first operation to my user 1, right? This will be done. It will take some time, okay? Till then, what user 2 has done is he has created the write request, right? He has created a write request. But before executing the write request of the user 2, there are two more read requests that the database has to serve of user 1, right? So again, right, again a kind of request will be sent, okay? Again a kind of read request will be sent. Again a response will be shown to the user 1. Again a kind of read request will be sent to the database. Again a kind of response will be sent to user 1. And after these three read write operations are done, then only the write operation of the user 2 will be performed. Till then the user 2 will have to wait, right? He will have to wait to get the right thing done on the database, right? So there is a kind of latency here that user 2 will feel, okay? And again read operation of user 1 will have to be done. Again this thing will be repeated. Then the read operation of user 1 will have to be done. Then this thing will have to be will be waited, and then user 2 will be waiting for the read request, right? And then read 1 of the user 1 will be done, and then the read of user 2 will be done, right? So here there is a kind of latency that will be felt by both of these two users, okay? Now, okay, if I delete these things, okay, now if I talk about the multi availability zone deployment, and that too where we are having one read and write instance and the other are only read only instance, okay? Now what if same kind of requests are there with this particular kind of I would say deployment or architecture? In this particular case, the read and write request will be solved something like this. So let's say one of the read request is sent to here, okay? Sorry, this is not write only, this is okay, this is read only, right? This is read only instance, okay? So the request will be sent to this particular instance, right? Let it be like this, okay? Again, let's suppose user 2 is reading something. It will be sent to this particular thing. At the very same time, okay, at the very same time, if the user 1 wants to write something, he will be redirected to this particular database instance. So in this particular case, my write database is not in a kind of deadlock situation, right? Here there was a kind of deadlock situation that was forming, that until and unless these three read operations are not done on the database, this write operation will not be done, right? This operation 4 will not be done. But here my operation 1, 2 and 3, okay, my operation 1, 2 and 3 are catered, or I would say are served from the read only instances, right? They are served from the read only instances, and hence my operation 4 can be done simultaneously, or at the very same time. There will be a no lag that will be felt by the user 1 in this particular case while performing the write operation, right? Similarly, there is some more read operations, so it can be catered something in the same way, right, on some kind of uh, read instances, right? And then again, let's suppose my user 2 wants to do a write operation. So write operation will be catered using this particular database. Okay. So here you can very clearly see that we will be able to cater both the read and write request simultaneously at the very same time. Okay. And there will be no kind of deadlock that will be formed in this kind of deployment. Okay. Here also you will be able to see, right, that this creates the primary database instance with two readable standby in separate availability zones. This setup provides 99.95% of uptime. Okay. So uptime means that if there is any kind of issue, at least this much, like any day. So if I check about this, right, so it means that over an year, okay, here you can see calculate downtime 99.95% here. So on an yearly basis, the only downtime, right, that is acceptable by AWS is 4 hours 22 minutes and 48 seconds. It means that it's not something like that for this much time my system will go down for sure. If the system goes down more than this, then you can sue AWS. Means you can do some kind of case on AWS that okay, this was a loss that I incurred because of you. Let's suppose if the downtime or if the uptime percentage is 99%, right? So if the database goes down for, let's suppose, 3 days and 15 total, I'm talking about on an yearly basis, right? So if my database goes down, right, for let's suppose 3 days, right, and because AWS claims that it has an uptime of 99.95%, so ideally it should only go down for not more than, okay, it should not go down, it should not it should not go down for not more than 4 hours and 22 minutes, right? If it goes down more than this, so we can do some kind of lawsuit on the AWS thing. Okay, so it is guaranteeing 99.95% of uptime. Okay, so redundancy across availability zones, right? So these as we have already talked about, that these instances will be in a separate availability zones. Okay, so again, if I come back here, so you can see increased read capacity, right? As already we have discussed it, that we will be having 3 reader instances. So obviously the read capacity will get increased, right? Reduced write latency, and this is what we have exactly talked about also, that how we will be reducing the write latency of the users, okay, with this particular architecture. Similarly, if we will go ahead with the 2 instance multi availability zone deployment, so it will have 99.95% of uptime, and the redundancy across the availability zones will be there, right? So all these instances will be deployed in different availability zones of the same region, right? And as we are already aware about the fact that all the availability zones in one region are isolated from each other, right? Here, if you see, there is nothing like increased read capacity and the reduced write latency. It is because the read and write operation will be only and only performed on the primary instance. This secondary instance will only be a standby instance. It means, let's suppose, right, let's say I am a user, right? So I'll be doing my write request and my read request from the primary instance itself, right? I will be not sending any kind of request on my standby instance. If by any chance my primary instance goes down, right, this availability goes down and my primary instance goes down, then I will switch to the standby instance. So I will do the read and write operation of the standby instance, and the standby instance will be a clone. So it will keep on copying the data from the primary instance to this standby instance, right? So the standby instance will be, you can say, a kind of carbon copy of my primary instance. So if in any case my primary instance goes down, my standby instance will be up and running. Here you can see if I'm going ahead with a single availability zone deployment, so the uptime is only of 99.5%. So if I check here as 99.5%, 99.5%, if I calculate the downtime, So it means here I have the downtime of 1 day and 19 hours, so nearly equal to 2 days, right? In case of a single availability zone deployment. So here we are already aware about the fact, right, that there will be no kind of data redundancy, that both the read and write request will only be done from this particular instance itself, and if this instance goes down, everything goes down, right? My whole system will go down, and until and unless again this particular instance is not available, my instance or my application will have to suffer. Okay, so here we will go ahead with the sandbox deployment itself. I hope these things are now also clear. We have already talked about in a theoretical way that there is multi availability zone deployment, there is single availability zone deployment, and now I hope that you guys have also understood how we will be able to do a single availability zone deployment. That is by default, there is nothing that we have to do in that particular case. How we can go ahead with multi availability zone deployment, that is there. And this is what the Amazon RDS service level agreement is, that is the SLA, talking about the uptime thing, right? So AWS is committed to a certain level of uptime depending on the deployment you choose. Okay, cool. So now let's move forward. So in the templates, choose the free tier, and this is done. So in settings of database instance identifier, enter MySQL for Lambda. So let me enter this particular name for the database identifier. Let me have the username as admin itself. So set up the username and password for following. So let the level name admin, and master password is, enter the password. So let me go ahead with self manage, and here I will choose a password as, let's suppose, root and root. Okay, so root. Okay, so here expand the section and enter the database example as the initial database name. Okay, so initial database name is, so instance configuration, let it be, right? So we will go ahead with TG micro. Rest of the things is not available. TG4G micro, this is T3 micro, so let's go ahead with T4 itself, it's fine. Okay, storage wise, like, we will go ahead with general purpose SSD, that is GP2, right? We can also go for provisioned IOPS, and we can also go for magnetic, but let's go ahead with the GPU itself. And where is the database option? Let me see. Specify the database name by doing the following. Leave all the remaining default options selected and scroll down to the additional configuration section. Okay, storage connectivity, additional configuration is here, and here we only have the database port. Okay, this one, additional configuration, and here we have an example of initial database name. Okay, so I can set up the initial database name as example DB. Okay, rest of the things we will try to keep it as it is. Okay, so instance configuration wise, if we want, we can choose any other configuration. If we will go ahead with multi availability zone deployment and these two deployments, so here more options of, I would say, clusters, or I can say instances will appear. Okay, but currently why to spend that much money? It's not I would say recommended to do it at right now. Okay, talking about the connectivity, so we will have all these things by default. Let it be by default itself. Okay, VPC, so choose existing VPC, default VPC. Okay, availability zone deployment, so if you have any kind of preference of availability zone, means if I want to go ahead with AP South 1A, maybe AP South 1B, AP South 1C, I can choose it, so it will hard launch in that particular availability zone, else it will try to decide by itself that in which availability zone the RDS instance should get launched. Okay, So the additional port, right, the database port by default is 3306. If we want to choose, let's say any other port, so we can do that particular thing also. Monitoring wise, we will go ahead with the standard monitoring part itself. Okay, we can enable enhanced monitoring. Maybe we can enable these logs, okay, for our service. Here we have set up the example or initial database name as example db. Parameter group is this, it's fine. Retention period is 1 day, more than enough for us. Here if we have any kind of backup window, right, now let's suppose if we are some kind of banking application, right, or maybe some kind of application where I am having a b2c kind of application, right, and I have to do some kind of maybe some kind of backup, or maybe some kind of you can say maintenance and all those stuff. So I can also choose a window, right, and for that window, let's say from 2 p.m. UTC, right, so 2 p.m. will be 7 here, no, so let's take it as, let's suppose 10 p.m. UTC. Okay, so 10 p.m. here will be 5.5, so 10 will be 2 and 3, 3:30. Okay, so let's keep it as 9. So 9 will be 2:30 at the midnight, right? So if I keep it as 9 p.m. UTC, right, and the duration is for half an hour, so it will do what? It will automatically try to create a window for the backup. So let's create it, even though we don't require any kind of backup. Let's create it. Okay, enable backup replication, right? So we can also allow some kind of replication in other AWS region if allowed, right? So I can enable a replication in maybe some kind of in a different destination region, right? Maybe in Hyderabad, Singapore, North Virginia, Ohio, or Oregon, or whatnot, right? So we can choose it from here, but currently let's not enable it. Okay, enable encryption. So encryption will be enabled. Our default key pair service will be this, right? Account is this, key pair ID is this, right? Maintenance is enable auto miner upgrade version, right? Maintenance window, again let's choose a window. So let's say on Sunday you can do it at 9 p.m. Okay, maintenance window and backup window cannot overlap, so let's make it from 9:32 p.m. Okay, and it will be again for half an hour. Okay, and enable delete protection and all those things. If we want to, we can do it, and then we will click on create database. Okay, leave all the things remaining and choose the default create a database. So let's first of all create the database, and then we will be able to, you can only create the associated resources of your database as completion, created completion, and is in available status, right? So first of all, we will have to wait until this particular status is in available mode. So it will take, I guess, 10 or 15 minutes. So we will have to wait for it. So either, right, I would highly recommend you guys, if this particular video has been cut, right, it has been cut, so you will automatically get to the availability status. Else, you guys can skip till the status of this particular database is in the availability zone, right, or it is, the status of it isn't available, I would say. So it will take, I guess, 10 or 15 minutes. Okay, so let's wait till then. Alright guys, so now we can see that our database instance is up and running. Okay, now let's follow the next step. So now we will create the Lambda function and proxy. So you can use the RDS console to create a Lambda function and a proxy in the same VPC as the database. So firstly, what we will have to do is, if I select this particular database, we will have to know about the VPC in which the database has been created. So the last digits are FE997. Okay, cool. So to create an associated function and proxy from the database page, check if the database is in the available status. If so, proceed to the next step, else wait till the database is available. Select the database and choose setup Lambda connection from actions. Okay, so what we can do here is we can go back to databases. I will set up the database, and from here I will click on setup a Lambda connection. So I will click on it. Okay. In the setup Lambda connection page, choose create new function. Set the new Lambda function name to Lambda function with RDS. Okay, so I will just copy this name. I will come here, and here I will click on create new function, and here I will name the function as Lambda function with RDS. I can also create this function manually and then later on attach to the existing function, or I can directly from the databases also I can create. In the RDS proxy section, select connect using RDS proxy option. Further, choose create new proxy. So for database credential, choose database username and password. For admin, specify admin. For password, enter the password that you created for your database instance. So I will come back here, right? I will connect using this. For database credentials, I will choose a username and password thing. For username, right, I have kept the username as admin itself, and my password was nothing but root. Okay, that's it. Select the setup to complete the proxy and the Lambda function creation. The wizard completes the setup and provides a link to the Lambda console to review your new function. Note the proxy endpoint before switching to the Lambda console. Okay, so I will just click on this connection summary, right? You can see right here exactly that we will be having a Lambda function using the RDS proxy, right? It will be able to communicate to the RDS, right? So here proxy means, right, that it will be a kind of an interface, or you can say an intermediary service using which the Lambda will be able to communicate to the RDS. I will not allow my Lambda function to directly communicate to my RDS. Okay, so if I show you proxy, okay, proxy meaning if I say, let's suppose, okay, in internet terms, okay, so you can see in the internet world, a proxy is an intermediary service that acts as a middleman between your device and the website service you access. Okay, so just like earlier we had our EC2 instance, right? So in that case, EC2 instance was acting as a proxy between our RDS and the user, right? If I talk about these architecture, right? So here we had a user, right? And we had an EC2 using which we were able to connect to our RDS instance. And in this particular case, the EC2 instance was acting as a proxy for our RDS instance. Similarly, here we have already created a RDS proxy. So I can say here that this is my RDS proxy. Okay, and using this RDS proxy, I will be able to communicate to my RDS instance using the Lambda function. Okay. Forwarding your request and masking your real IP address to provide security, privacy, and control over the internet traffic, often hiding your location and filtering out the content. Okay, so this is what exactly a proxy is. So this is done, and here you can see the default firewall group is default and RDS proxy 1, this is firewall 1, right? Lambda function with VPC, so you can see here that the VPC that it is using is the same VPC of our database, that is FE997, right? Subnets and firewall it has created, and I will just click on this setup. Cool. So I can just click on this view details and you will be able to see all the details here. Okay. And here what do I have to do is I have to copy the endpoint, right? So here I had to copy what? The visit completes and setup shows the link of the Lambda console to review the new function. Note the proxy endpoint before switching to the Lambda console. So proxy endpoint is register proxy target, create proxy this. Or even though I can do what? I can just click on this, right? And here also I will be able to get my endpoint. Okay. Now to create a function execution role. So before you create a Lambda function, you create an execution role to give your function the necessary permissions. For this tutorial, Lambda needs permission to manage the network connection to the VPC containing your database instance and to poll messages from the Amazon SQS. Okay, means it will check that if any kind of new message has been added to the Amazon SQS queue, right? As well as it will also have the ability, or it should also have the authorization to connect to the VPC of the database instance in order to insert the data into the table. Okay, to give your Lambda function the permission it needs, this tutorial uses IAM managed policies. These are the policies that grant permissions for many common use cases and are available in your AWS account. For more information about managed policies, you can go on to this particular link. So to create the Lambda function, to create the Lambda execution role, open the roles page of the IAM console and choose create role. So I will just click on this roles page. Okay, and here I will click on this particular button, that is nothing but create role. Okay, again create role. For the trusted entity type, choose AWS service, and for use case choose Lambda. Okay, so here I will choose trusted entity type. I have to choose AWS service. So AWS service, and for use case I have to select Lambda. So I will say Lambda. Okay, then choose next. Okay, so I will go here and I will choose next. Add the IAM managed policies by doing the following. In the search query, search for IAM AWS Lambda SQS execution role. So I will just copy it. In this search button, I will search for this and I will check it. Okay, and then I will come back. In the result list, check the box in the role and then choose clear filter. So I have checked the box and then I will clear the filter. Okay, so you can see here one permission has been selected. Now I will come back here and I have to select the new policy, that is AWS Lambda VPC thing, right? So I will come here and I can search for AWS Lambda LAMBDA VPC execution access execution role. Okay, and then again I will be able to clear my filter. So you can see we have selected two policies now. Okay, so in the result list, check the boxes and click to the next in the role to choose next. So here I will come back and I will scroll down and I will click on next. Okay, so I have to enter the role name. So for role name, enter Lambda VPC SQS role. Okay, so I will just copy this. I will paste it here. Okay, so these are the two policies that we have attached, that is AWS Lambda SQS SQS queue execution role and AWS Lambda VPC access execution role. Okay, if I want to edit it, if I want to add any other role, if I want to remove some role, I can do it also. And then I will click on this create role button. So it will start creating the role for me. Okay. Later in the tutorial, you will need the Amazon resource name of the execution role you just created. So to find the ARN, go to roles page and choose AWS Lambda SQS role. Copy the ARN displayed in the summary section. So currently we don't need it. So let's move forward. We will do it later on. So I will just have to go here. I will search for RDS. Sorry, what was the name? Lambda VPC, right? So Lambda VPC SQS role. Okay. And here in the summary section, I will be able to copy this particular ARN. Okay. Now create a Lambda deployment package, right? So the following code example uses my Python SQL package to open a connection with your database. The first time you invoke your function, it creates a new table called customer. The table uses the following schema, which is customer ID in the primary key. Okay. So our customer table will look something like this. That is customer ID, which is a primary key, and there will be a column named as name. Okay. So we will have two columns in our customers table, right? And we will be using Python and SQL to communicate between the databases, like the Lambda function and the RDS instance. The function uses PyMySQL to add record to this table. The function adds records using customer IDs and the name specified in the message that you will add to your Amazon SQS. The code creates the connection in your database outside of the handler function. Creating the connection in the initialization code allows the connection to be reused by subsequent invocations of your function and improves performance. In a production application, you can also use provisioned concurrency to initialize a requested number of database connections. These connections are available as soon as the function is invoked. Okay. So you can see right here that this is the function that we will be using. Okay. So first of all, we will import sys, we will import logging, we will import PyMySQL. That will be a kind of library using which we will be communicating from our Lambda function to the RDS instance. Then we will import JSON and we will import OS. So read settings. So username will be os.environ. It will pick up the username. It will pick up the password. It will pick up the reverse proxy host, and it will pick up the database name. Logger we will be using, and we have set the logger level to info. So try if it will try to first of all connect to my SQL database client. In this case, my database client is nothing but my RDS instance. So PyMySQL.connect host is the RDS proxy host, right? Username, password, right? And the database name we will have to do. If there is any kind of error, we will get that unexpected error could not connect to the MySQL instance. And if this try statement is done, then we will log success, connection of RDS instance is succeeded. Then we have the Lambda handler function where we will have an event and we will have the context. So this function creates a new RDS database table and writes record to it. So message will be equals to event, right? Records of the 0th index, and then we will have the body. Data is json.load. We will load the message. Customer ID column will be, so it will become something like this, right? So our structure will look something like this now, that we will have a JSON file where we will have customer ID. So this JSON file will be named, let's suppose, as data. Okay, so data is equals to this, and inside this data we will have a column as customer ID, which will have some kind of value, and we will have name, which will have some kind of value. So this value will be inserted into the customer ID column, and we will have name. So the name value will be inserted in the name column. Okay. Now if item.count is equals to 0, right, insert into customer. Okay, first of all, we have initiated a variable item count that is equals to 0, and this is the string, right? Insert into customer into this ID, and the values will be dynamic, right? So now with connection, right, this is the connection that we have opened here, right? Connection.cursor, as cursor. So cursor dot execute, create table if not exists, right? Customer ID where integer is not null, and name is varchar having 255 characters, which is also not null, and primary key is nothing but our customer ID. Then it will execute customer string and customer ID and name. Okay. Connection dot commit, connection dot execute, select star from customer, and logger info. The following items has been added to the database. Now it will give us the info that okay, these many are the number of rows that has been added to the database, and it will return added %d items. Means here we will get this items count, right? Item count items to the RDS table. So it will basically, this item count number will keep on increasing for every row it has inserted into the table. Okay. Note, in the above example, your database access credentials are stored as environment variables. In production applications, we recommend you to use AWS secrets as a more secret option. Note, if your Lambda function is in a VPC, to connect to the secrets manager, you need to create a VPC endpoint, and you will be able to do it given in this particular link. Okay. So to include the myPHP dependency in your SQL, in your function code, create a zip deployment package. The following command works on the Linux, Mac, and the following command work for Linux OS, Linux, Mac OS, or Unix. Okay. So what we will do is to create a zip deployment package, save the code example, example code as a file named lambda function.py. Okay. So I can do it in this way. Okay. Can open my directory. Okay. I can do this, or in the same directory in which you have created the Lambda, create a new directory named as package and install the okay. Got it. Okay. So here what I will do is, so let's create first of all a new folder. Let's say, right. Let's suppose I'm naming it as lambda hyphen RDS. Okay. So inside this lambda hyphen RDS connection, first of all, I will create a new file named as lambda function.py. Okay. So I will click on this new, not a text file. Okay. Let me do one thing. Let me open my VS Code, open folder, and I will select lambda, open this. Okay, and here I will try to create lambda function.py. So I will just copy it, paste the name here. I will copy this code and paste it here. Okay. There is a problem in this file. What's the problem? Okay, MySQL cannot be resolved. No worries, I will just resolve it. Okay. And then what I will do is, in the same directory, you need to create your lambda function.py, create a new directory named package, and install the PySQL library. So I will do what? Here I will create a new directory called as package. Okay. And here I will run a command as pip install hyphen hyphen target package, and you have to install this. Okay, so you can see now that PyMySQL and PyMySQL test info has been added to the package thing. Cool. Now create a zip file containing your application code and the PyMySQL library. In Linux or Mac, run the following CLI command. In Windows, you can choose your preferred zip tool to create the lambda function.zip file. Your lambda function.py source file and the folder containing your dependencies must be installed in the root of the zip file. Okay, so I will do what? I will come back to my this, right? I will go to D, and here I will convert it into a zip. So I will right click it, okay, and using 7-zip, I will compress to, I will rename it and not, I have to email. I can add to lambda.connection, or let me just rename the folder as, okay, renaming will not work. I can rename afterwards also, because I have opened it in the MySQL, right? So it will not rename. So add to lambda.zip. So this is the zip file it has created. Okay. Now the name should be lambda function.zip. Okay. So let me copy this name. Come back here. Rename the file as lambda function. And here in the lambda function, okay, do control X, control V. Okay, let me do one thing. Let me delete it. Let me close it. Let me rename it to lambda underscore function. Okay. Then I can compress to zip file. Okay, it should be in the base package, right? We have two lambda functions. Okay, then let me do one thing. Okay, cool. And now let me move this lambda function to D. So here now you can see that inside the lambda function, so you have to make sure that in your zip file, it should be in the base. My .py file and my Python package folder should be in the base folder itself. It should not be inside another folder. Else it will give us an issue. Okay. So must be installed at the root of the zip file. Okay. So you can also create your deployment package using the Python virtual environment using this, right? Now update the lambda function. Now using the zip file you just created, now you can update your lambda function using the lambda console. To enable your function to access your database, you will need to configure the environment variables to your access credentials. To set up the lambda functions, open the functions page of the lambda console and choose your function. So we can click on this particular link and we will be redirected to the lambda console, right? So this is the function that we have to edit. So I will just click on it, right? And it will open us this particular page. Now in the runtime settings tab, select edit and change the runtime to the function to Python 3.10. So I will come here and here in the runtime tab, okay, so we should have somewhere the runtime tab. yeah, runtime settings, right? Here we have, so here we have to edit it, and we have to choose our runtime to Python 3.10. So Python 3.10 is here. Okay, to Python 3.10, change the handler to uh, lambda function dot lambda handler. Okay, so I can just copy this name, come back here and paste it here. Okay, in the code tab, upload the file. Okay, so first of all, let me create it. Let me save this. Okay, and now in the code tab, you can see right here we also have our VS Code available, right? Or else what I can do, successfully updated the lambda function. Okay, and now my runtime should be Python. It's fine. Okay, so here you can see in the code tab, choose upload from and then zip file. So I will come here, I will click on this upload from, and I will choose .zip, and I will just click on this upload. Go to my D drive, and here we have lambda function. No, this is not the zip one. Zip one is this. Okay, and click on open. So for the file uploading history, so our file is not that much big, so I will just click on save. Okay, .zip, select the lambda function .zip you created in the previous stage and choose save. Now configure the function with the execution role you created earlier. This grants the function to grants the function permissions it need to access the database instance and poll the SQS queue. Okay, so to configure the function execution role, in functions page of the Lambda console, select the configuration tab and then choose permissions. Okay, so first of all, let it happen. So you can see all the code is now here in our environment. Okay, and now what we have to do is I have to go into this configurations tab. Okay, and in this configurations tab, I have to choose permissions. Okay, so I will come here, I will choose permissions. Okay, and then I will click on add permission. So even in the documentation, you will be able to see permissions. So in the execution role, choose edit. Okay, so execution role, I can even choose edit. And here in the existing role, choose the execution role, that is Lambda VPC SQS role, and then click on save. Okay, so here we have to select Lambda VPC SQS role. Okay, and we have to do select, we have to, if we want to give any kind of description, right? Memory is this much, ephemeral storage is this much, snapshot start timeout is 3 seconds. Let me increase the timeout to, let's suppose, 30 seconds. Okay, create using an existing role, and that's it, and I will click on save. Right, now to configure your functions environment variables, go to functions in the Lambda, select configuration tab and choose environment variable. So I will come here, and if I will scroll down, I will have a button called as environment variable. So I will click on this environment variable, and I will click on the edit thing, choose edit, and add database access credentials to the following. So choose environment variable, enter username. Okay, so I will click on this edit. Okay, add environment variable. So key will be user hyphen name, right? And username is nothing but admin, right? Then environment variable name is db name, it's nothing but example db, so db underscore name, right? And the value is example db. So let me copy and paste it here. Now password, so password we have nothing but root, right? So if I do password, and here the password is ROOT. Okay, then the last is RDS proxy host. Okay, so RDS proxy host, and the RDS proxy host we will get it from here. Okay, so view details, and here I will be able to get my. So here we have to, sorry, here we have to give the proxy endpoint. So where we will find the proxy endpoint for this particular Lambda function is here. If you will scroll, right, so you can see here as proxies, right? So you can click on this proxies. So currently, because we have only one particular proxy available, so I can click on this proxy, and here you will be able to see proxy endpoints, right? So this is the endpoint that we are looking for. So I will click on this, and I will attach this particular endpoint to my proxy RDS proxy host value. Okay, and then I have to go what proxy host, and then I have to choose save. Okay, so I have to click on save. Now test your Lambda function in the console. So now you can use the Lambda console to test your function. You create a test event which mimics the data your function will receive when you invoke it using the SQS in the final stage of the tutorial. Your test event contains a JSON object specifying a customer ID and a customer name to add to the customer table in the functions creates. So to test the function, open the functions page of the customer of the Lambda console. Choose your function, choose a test section, choose create new event, and enter my test event for the event name. Copy the following code event JSON and choose save. Okay, so I will click on this. Okay, and then here if I go on code, sorry, on test code, right? So I will click on create new event. Okay, and here I can give the event name as like this, uh, my test event. So control C, control V. Okay, and in the following code, just copy the following code into the event JSON and choose save. Okay, so here in the event JSON I can paste it. Okay, and I will click on save. So save is here. Okay, and then I will choose test. So here I can click on, so just let me cross this, and I will click on test. Okay, so execution failed. Ideally it should give execution time similar to the. Okay, so let me see why my execution got failed. No module named PySQL. Okay, but here I have uploaded it. In the package, I have my PySQL thing ready. Is it giving me in the error in this case then? Okay, ideally it should work. Let me do one thing. Package with hyphen r. Okay. Contain a zip file of your application. Create a zip file containing your application code. That's my library, right? The following create function.zip file, your lambda function.py source code file, and the folder containing your dependencies must be installed at the root of the zip file. Hmm, this is fine. I don't need to zip the package file, right? Mkdir package. Okay, pip install target package mysql. Fine. I will cd to package. Okay. Zip hyphen r dot dot the function dot zip the base environment. Then cd. So I will go back here and lambda function dot zip lambda function. I Okay, so I have to create even the package in a zip file. Okay, let me just verify it. So I will have to package this also. Let me do one thing. But ideally the package here is fine. Okay, let me do one thing. Let me go to test. I need to find this import summary. Most likely there is an issue in the function code. However, in rare cases, a lambda runtime update can cause an unexpected behavior for the function. Using runtime, update the trigger and you can apply automatically. To determine if the runtime is update, check the runtime version. Okay, okay. So let me do one thing. Okay, let me also show you guys how we will be able to fix the error. So I will do what? Upload a file. I will just upload my lambda function. Okay, and then copy it, or I may copy this thing. Okay, let me paste it here. Packaging mistake. Okay. Mkdir package. Okay, so let's do one thing. Start clean. Okay. So this is another packaging mistake. Lambda is telling you exactly what's wrong. Is not inside the deployment package. No guess what. What is happening? Plain truth. AWS Lambda not included in. So zip either does not contain or contains the wrong directory level. Lambda is looking for the zip root and this. So this is my current directory. If I can show you also, you can just open my snipping tool, copy it and paste it here. So this is my current folder structure in Lambda. Okay, got it, got it. You can also add a layer here, right? If I come here, mm, only for the structure, here Python, PyMySQL. Okay, so I will do this. Lambda function package. Okay, options. Can't I directly create a zip of it? Compress to zip file. Package.zip. Okay. Mm, Now I will be able to do what? Custom layers. Or maybe let's do one thing. Okay, so this is done. Package is zipped. You can remove this package now. Come back here in the D directory, and now let me compress it to zip. Okay, and if this is done, sorry, no, my bad. Let me delete it. Lambda function, and then I will have to compress to zip file. Okay, not like this. Okay, let me do one thing. Okay, let me do one thing. Why does it fail? AWS Lambda looks like subfolder like package for Python modules. Lambda only searches zip.root. Okay, so opt -python lambda less. Okay, so when you run import, lambda says note not in the root and this mask. Okay, the only correct folder structure zip must look like this. Okay, okay, got it. But okay, there should not be this package thing here. If I do it like this, maybe will it move or not? Okay, I will have to install CLIs and all. Okay, let me do one thing. If I delete, okay. Okay, and now if I go to test, cool. So now we can see that our update with the Lambda function was successful, right? So we are here in the success that added one item to the test my table. Okay, so here the status is succeeded, and here in the test function also you will be able to see the summary something like this. Okay, so I did it. I did it according to this only package and all those stuffs, but ultimately the package is not required. Okay, it should be inside the root folder itself. Okay, now we will have to create what? We will have to create a SQS service. So create an Amazon SQS service so you can you have successfully tested the integration of the Lambda function and the Amazon RDS database instance. Now you can create the Amazon SQS you will use to invoke your Lambda function in the final stage of the tutorial. So create the Amazon queue using the console. So open queues page of the AWS console and select create queues. So I will just click on this queues. Okay, and I will click on this Okay, I will click on this create queue. Okay, leave the type as standard and enter Lambda RDS queue name for the queue. So I will leave it as standard, and here in the name I will do is leave all the default options selected and choose create queue. Okay, so here we will have the visibility timeout thing, delivery delay, receive message, wait. Message retention period is 4 days. Maximum message size is 124 KB. Right. Here we will have the standard type of queue and the FIFO kind of queue. That is first in, first out. Encryption is enabled. Encryption type is Amazon SQS key. Access policies, right? All these things are given here. Retrieve allow policy, dead letter queue, tags, and all these things. And I will just click on this create queue. Okay. Now create an event source mapping to invoke your Lambda function. Okay. So an event source mapping in Lambda resource which reads the items from the stream or the queue and invokes a Lambda function. So you can configure an event source mapping. You can specify a batch size so that records from your stream or queue are batched together in one single payload. For example, you can set up a batch size to 1 so that your Lambda function is invoked every time when you send a message to your queue. You can configure the event source mapping either using CLI or the Lambda console. So to create an event source mapping from console, open the functions page and select your function, that is our RDS function. In the functions overview section, choose add trigger. Okay, so I will have to go to my Lambda console, right? And here in the functions part, I will have to select my thing. Okay, and here in the functions overview, I will have to click on add trigger. Okay. Now for the source, select Amazon SQS and then select the name of the queue. So I will click here as source. I will select as SQS. Okay. And here I can search for the queue. So this is the queue that we have created, right? Lambda queue service, and rest of the things for the source. This is the Lambda RDS queue. For a batch size, enter 1. So here in the batch size, I will enter 1. Okay, so that for every single row I am entering to my SQS, it will trigger my Lambda function. If I let it be here as a 10, in that particular case, I will have to, like, my SQS should have at least 10 records. Then only it will trigger a Lambda function. If the number of records is less than 10, in that case, it will not trigger my Lambda function. Okay, so let me make it as 1. Leave all the other options as a default and default values and choose add. Okay, so I will come here and I will choose the option of add. Okay. So here now you can see that using SQS, my Lambda function will get triggered. Now you are ready to test your complete setup by adding a message to your SQS. Now test and monitor your setup. So to test your complete setup, add messages to your Amazon SQS using console. Then use the CloudWatch to confirm that your Lambda function is writing correct records to the database as expected. So to test and monitor the setup, open queues page of the Amazon SQS console and select the queue, Lambda RDS queue. Choose send and receive messages and paste the following JSON into the message body in the send message section. Okay, so I will have to go to queues. Okay, I will select my queue and here I will have to select this send and receive message. And here in the message body, right, I will be pasting this particular value, that is customer ID is this and name is this. So let me paste it here. Okay, choose send message. Okay, so I will click on choose send message. So you can see your message has been sent and is ready to be delivered. Okay, so sending your message to the queue will cause the Lambda function to invoke your function through your event source mapping. To confirm that your Lambda function is invoked as expected, use the CloudWatch logs to verify the function as written in the customer name and in your database table. Now open the logs group page of the CloudWatch console and select the log group of your function, that is AWS, Lambda, and RDS. So I will open this particular page. And here I can select this AWS Lambda, uh, Lambda functions with RDS thing. Okay. So in the log stream section, choose the most recent log stream. In your table contains two customer records, one of each invocation of the function log stream. You should see messages similar to the following, something like this, right? So if I come here, right, and if I choose any of the log stream, let's say, so here we will be able to see, right, this thing, that the following messages has been added to the database, right? This is the one earlier which we did, and here the thing that we sent via our message, right? This where did it go? CloudWatch here, right? Richard row, right? If I want to add another message, right? Let's suppose if I'm writing customer here ID as 3896, something like this, right? And here if I want to add my name, okay, let's say it is Vishal Singh, okay, and that's it. And I will click on this send message button now. Okay, so your message has been sent successfully and ready to be received. Okay, so here if I will go back to the CloudWatch, now I will have to open the latest log, right? So okay, if I refresh it, okay, cool. Here you can see now that the new value, that is Vishal Singh, has been added to my database. Okay, so here in the logs thing, we are able to see each and every single detail, right? Now we have to clean up our resources. Okay, so now we have successfully achieved, right, whatever we were trying to do. That first of all, we created an RDS instance that was having a MySQL engine installed on it, or I would say a MySQL database instance installed on it, right? Then using the RDS proxy, we were able to connect our RDS to a Lambda function, right? And our Lambda function was getting triggered using the SQS, that is Amazon SQS, that is simple queue service. And whenever we are trying to add any values to the SQS, right, simple queue service thing, it is getting triggered, right? Here if I even come to the monitor part, okay, I'll be able to see the invocations, right? So first of all, it was invoked here, then it was invoked here, and then it was invoked here, right? Now if I try to do it in this way, let's suppose, okay, if I go to SQS, okay, if I click on this edit, okay, Okay, cool. So here, if I just try to do something else, right? Let's suppose if I change this number, right, and if I put some other value here, right? Let's suppose anything, right? Sudhanshu Kumar. And if I want to add another customer, so I will just do what? I can have the values something like this. Control C, Control V here. Okay. Because it is a primary key, so it cannot have the repetitive IDs. And here I can put some other value, right? Let's suppose as Rahul Sharma or something, whatever, right? And that's it. So now it will have two records. If I send it, okay, so your message has been sent. Now if I come to my CloudWatch, right, and if I refresh it, okay, if I come back here, if I refresh it, so it got invoked. It's fine. Okay, this one is for test only. So here in the CloudWatch, ideally it should receive it. If I do something like this, let's say, okay, send message. I go to my CloudWatch, refresh it. Okay, so Sudhanshu Kumar has been added. If I want to add multiple records, in that case, if I go to my CloudWatch now, hmm, not very sure why it's not adding these multiple records. Message, refresh it. So yes, Rahul Kumar got added. Okay, okay, I now understand. I now understand why it's not adding multiple records. So okay, now this is the JSON format. Okay, got it. Okay, so why it's not able to add multiple records, right? Currently is because if we add multiple records, right, it's trying to add, okay, it will try to add it in one single row itself. But currently we are having only customer ID and name, right, in our table. We will not be able to add, you can say, four columns into two tables, right? It's not possible inside a, sorry, it's not possible inside an RDBMS. Okay, so for that reason we are not able to add basically uh, the multiple records in the same go. Okay, so yeah, so this is how, right, we will be able to basically trigger our Lambda function using an SQS, and we will be able to store it in our RDS database, okay, which is right here, and we are protecting our database using the proxy. Okay, now we will try to delete these instances. Okay, so I will come here, right, to each and every function, or sorry, each and every service, and I will one by one try to delete it. So I will select my first of all queue, go to this actions, sorry, here only you can see this delete button, right? So you can click on delete. I will write confirm, and make sure, guys, to delete each and every service that you have used in this particular video. Otherwise you will get charged for it. Okay, so I don't want you get charged for it unnecessarily. So just try to delete all the services that we have used. So our queue, it's fine, it's empty now. Okay, for Lambda functions, I can click on this Lambda, click on this, go to actions, and click on delete. Okay, and here I will write confirm. Okay, delete, and if I refresh it, you can see there is no data to display. So our Lambda function has been successfully deleted. Here if I come and if I try to do anything, okay, so here you can see there is no Lambda function, so I can delete it. And IAM roles, let it be, we don't need to delete the roles here. Now we need to delete our RDS instance, so I can again go to actions, click on this delete button. I will uncheck this particular creates final snapshot. I will uncheck this retain automated backups, and I will check this I acknowledge that upon creating upon instance deletion, automated backups and all these things will be no longer available. And here I will try to write delete me, and then I will click on this delete button. Okay, so it will take again a few minutes, not a few minutes, I would say only 1 or 2 minutes to delete each and everything. So now you can see that we have received the message that successfully deleted the database instance. And now if I even refresh it, so I will not be having any kind of service of RDS, SQS. Is again we are not having any kind of service. It means we have successfully deleted all the things. Okay. Okay, here it's saying to delete the role also. So let's delete the role. No worries with that. So the role was named as this one, right? Lambda VPC SQS role, right? This also I can delete. It was created 1 hour ago. This also I can delete. Or maybe let me only delete this role. So copy it here. Delete it. Okay, so role is also deleted, database instance is deleted, and the SQL service is deleted. So now we will not be charged for any of the service that we utilized in this particular tutorial. Cool. So this was pretty much it, guys, for this particular video. I hope you guys have understood that how using a Lambda function, right, we will try to invoke, and the Lambda function will get invoked using a SQS, that is a Amazon simple queue service. We will try to we were trying to mimic the SQS as a kind of data source, right? So the SQS triggered our Lambda function, and our Lambda function was creating, first of all, created a table if it did not exist, and once the table was created, it was adding the data in that particular table, right? And we were communicating from our RDS and Lambda via a RDS proxy. Okay, so this was a kind of trigger based or an event based data storage system, where on some kind of event we will be triggering something and we will be storing our data into the database. So I hope you guys learned something new in this video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye.